Is part 2 of the solutions to the practice exam 2, and all of these questions are over material that was covered in chapter 5. The first asks that we determine whether a probability distribution is given. The question on the exam will only have one distribution, and it will be a probability distribution. In the practice we had 2 to choose from, but in the actual on the actual exam you'll just have one. Then we're asked to determine the mean and standard deviation from this probability distribution. And to do that, we multiply each random variable times its corresponding probability. So here we have 0 times 26. 0 times anything is 0. 1 times 0.29. 1 times 0.29 is 0.29. 2 times 0.24 is 0.48, and 3 times 0.21 is 0.63. Now, if you add all these, then that total is 1.4, and that is the mean. Then in this fourth column, we subtract that mean, minus 1.4, we subtract that mean from each of these random variables, and then square that value, and then multiply it by its corresponding probability. So the first calculation is 0 minus 1.4. That quantity is squared. We multiply that times 0.26, and we have a value of 0.5096. In the second row, we subtract 1.4 from 1, square that, multiply that times 0.29, and that value is 0.0464. Continuing on, 2 minus 1.4, that quantity squared, times 0.24 is 0.0864, and then 3 minus 1.4 squared times 0.21 is 0.5376. When you add all those up, you'll have 1.18, and that's the variance. Well, since the variance is 1.18, standard deviation is going to be the square root of that, and that's approximately 1.086. So that's question 6. Now it's worthwhile, maybe, to take a look at how we would do that in Excel, because it's efficient, it's convenient. So I'm going to go ahead and label each of the cells in the top row. I'm using the asterisk for multiplication because that's the that's the operator for multiplication in Excel. It's also what is shown on your calculator when you enter in multiplication. And now here's all the random variables under the X. So that first row is just labels. So I type 0, 1, 2, 3. Okay, and then the probabilities for each of those are 0.26, 0.29, 0.24, and 0.21. Now, because I'm going to repeat this operation that I'm about to enter into this cell, I'm going to enter it in once and then auto-complete that. What I want to do now is multiply, so I type equal, so that Excel will know it's supposed to do a calculation. And the two cells I'm going to multiply are A2 and B2, so I will type in A2, and then multiply, and then B2. I hit enter. Excuse me, and of course, as expected, this value is 0. And then I'll grab the little square in the lower right corner and click and drag that down over the next 3 cells. As I mentioned before, my computer's a Mac. In Mac's version of Excel, this border and that square are blue. If you have a Windows computer, it'll be green, but it's doing the same thing. And now finally in the last cell, I'm going to subtract the mean, and I used an M for the mean in my label. I'm going to subtract the mean from each X value and then square that quantity. So I type equal, but I need a left parenthesis because I want this quantity to be it's the entire quantity to be squared, so I need it to perform this operation, the subtraction, first. So I'm going to subtract x, which is the in cell A2, minus the mean. Now we found earlier that the mean was 1.4, so I'm just going to type 1.4 in and close my parentheses. If you type the cell, which we don't actually have that value yet on the Excel spreadsheet, but if you type that cell in, there's a good chance that it won't autocomplete properly because you won't know to put a $sign in. I can show you that if you want in a second. Or I guess you don't really have any choice because here I am making this thing and you're just listening. So now the caret tells us to raise this to an exponent. I type 2, so that means it's going to raise it to the exponent 2. Then multiply, and now the probability is this cell, B2. And so I'm going to multiply by that value, and then I hit enter, and I get the same value that you see up here in the document. And then I'll go back to that cell and autocomplete, and I get all the values that match these that we've already seen. Now, to find the mean, I'm going to add all of these x times p of x, and so I'm going to type equal. And so far in class I've always used the sum command. You actually can use this little function up in the menu bar. Now it's not in the same place on the Microsoft version, but you'll see the sigma notation. I think it's way over here in Microsoft's version of Excel. But you just click on that and click sum. And I think the reason it knew to add C2 to C5 is because I had highlighted them a few seconds ago. I'm not sure. But it's going to give us that sum, which is 1.4. Now that cell is C6. If you wanted to use that cell in your in entering your formula, instead of 1.4, you would type in C $6. And when you do that, it's what it's telling Excel is when we autocomplete, for that one value, don't deviate from this cell. Use that cell for each of the subsequent calculations. So I hit enter, and I get the same value I had before. And then when I autocomplete, we get the same values, but you'll see that each time it'll reference these two cells, but for that one portion of the calculation, it sticks to that cell, C6. Okay, so that's enough of that. And then to find the variance, we do the same thing. We type sum, it adds those 4. That is my variance. And then if you want the standard deviation using Excel, you type equal. And the command for square root in Excel is SQRT. SQRT, square root, left parenthesis. The cell you want the square root of is D6. Close your parentheses, hit enter, and it's 1.086. So just like what we got doing the calculations by hand. All right, so that's how you would answer that question using Excel. Okay, now in question 7, you have a probability distribution given, and all you're being tested on in this question is your ability to read the table. So we're asked, what is the probability that the number of successes is exactly 2? Well, that's what this is. The number of successes out of 5 trials. Out of 5 trials, that's the among 5 randomly selected adults part. And the probability of exactly 2 is right here, 0.332. So the probability x is exactly 2 is 0.332. Next, we're asked, what's the probability that x is more than 2? Well, what's more than 2? 3, 4, and 5. So you add each of those probabilities for the total. 0.171, 0.044, and 0.005. So you add all those up, you get 0.22. In the last one, we want to know the probability that the number of successes is at most 2. At most means that's the most that it can be. That also means that the probability that x is less than or equal to 2. Well, if the most that the number of successes that we can have is 2, then we can have 2, 1, or 0. So we add those probabilities, 0.125 plus 0.323 plus 0.332. And that gives us a total of 0.78. That's all we're doing in that question. Now in question 8, we are asked, does each one of these represent a binomial distribution and a binomial probability distribution? And if so, what is the n, the number of trials, and what is p, the probability of success? If it is not a binomial distribution, we have to state at least one of the requirements that is not met. Part A, an oil company drills in an area where the probability of striking oil is 0.32. The company drills a number of holes until they strike oil. The procedure does not have a fixed number of trials, so that's what is violated in this case. That is the requirement that's not met. Because drilling until you got what you want, that's not a fixed number of trials. It's probably the best way to go about it if you're drilling for oil, but it's not a fixed number of trials. Part B, a clinical researcher examines 53 patients for a certain non-communicable disease that affects 12% of the population. There is a fixed number of trials because it's 53. The trials are independent, and that's reinforced by the fact that this is a non-communicable disease. Each trial is classified into 2 categories. Are you infected? Are you not? And the probability of success is 12%. You might not consider being infected 12%, but that's the thing that we're interested in studying. So that is the probability of success to which we refer. Now in Part C, the businessman is concerned that customers are not buying enough of his products. The probability that a customer entering his store purchases a product is 0.93. He surveys 30 customers' purchases and records how many items they bought. There is a fixed number of trials. The trials are independent, but each trial is not classified into 2 categories. Bought, not bought would be 2 categories, but how many items they bought is not 2 categories. So that's the requirement that is that's violated in this case. And I'm going to stop this now and put 9 and 10 on a separate 3rd video.